In this video, I am going to be teaching you about plotting graphs and functions. So, a quick introduction about functions. Functions are something like this: y is equal to 2x, or f of x is equal to x squared. These are the type of functions you typically come across. So, first I am going to show you how to graph some functions. So, we have the function y is equal to 2 of x. So, here y is this variable over here and x is a variable over here. So, here we have the x-axis and the y-axis. So, if we have x is equal to 1, then y is equal to 2 times 1, and that's 2. So, if we have a value 1 over here, then the value here is going to be 2. So, and if we have 2 over here, the value is going to be 4. And if we have 3 over here, the value is going to be 6. So, it will continue like that for every value here. So, we will get 1 here. And you can see that we have a straight line here. We have a straight line. My effort in drawing line. So, we have a straight line here. And there are many more functions like this. This is just one of them. So, now you know what a function is. So, now let's look at some more examples. Okay. So, let's look at y is equal to x squared. This is a bit more intermediate example. So, suppose we have 1 here. We have 1 here. Then we will also have 1 here, because if we have 1 squared, it's just 1. If we have 2 here, we will reach 4. If we have 3 here, we will reach 16. Sorry, we will reach 9. And we can do this in the opposite side. Here we have negative 1. The square of negative 1 is 1 itself. So we can write 1 here. And here we have negative 2. And the square of negative 2 is 4. So it will continue in this fashion upward. So we can draw a graph and it will look something like this. It will look something like this. And this is called a parabola graph. And this graph is always changing. This graph is always changing, and it's changing in it's changing at each point. And unlike the graph of 2x or x, it does not have a fixed path. It always changes. Sometimes it's like this, and sometimes it's like this, and sometimes it's like this. It's not predictable. So, let's look at functions. Here we have looked at plotting functions, and now let's look at functions. So, we have a function f of x is equal to sine of x. F of x is equal to sine of x. So, this function tells us that this function is built upon the variable x. The variable f depends on the variable x. So, if we have f of 30 right here, and I am doing this in degree, we will get sine of 30. We will get sine of 30. And that's equal to 1/2. So, we will get f of 30 is equal to 1/2. So, this is very useful in many situations, and I will show you. So, this is the equation we have right over here, and I have graphed it pretty well. So, not to brag, okay. So, we have the equation over here, and this v stands for velocity, and this t stands for time. With this equation, we can graph an object's velocity, its acceleration, its displacement, and many more things. So, I'll show how. So, we know that displacement is equal to velocity times time. If you don't know that, now you know that. So we have this equation over here and we can use this equation right here. So this equation tells us that the velocity times the time is equal to the displacement. The velocity is this axis and the time is this axis. This tells us that the area under this curve over here is the displacement of that object, whatever that object is. So this is the displacement of that object, the area under this curve. And we are not going to be learning about how to find an area of a curve. Instead, we are going to focus on some examples. So we can find the area of an object like this. Area of an not an area of an object, the displacement of an object if we have the velocity and the time curve. So that's pretty useful. And now we can I challenge you to find the acceleration at this point, at point 1. So the first step in that is finding the y point of that. So we are going to write it. We want to find v of 1. We'll say like that. So we want to find v of 1. So we'll write substitute the values here and we'll get 3 times 1 minus 1. So we'll get 2. So the value here is 2. So we can write it as 1 over 2. So this is the value here. And if you want to find the acceleration, we have to know the value, we have to know the formula of acceleration. And if you don't know the formula of acceleration, here's the formula. So acceleration is termed as change in velocity divided by change in time. That just means a final velocity minus an initial velocity divided by the change in time. And this final velocity does not have to be that large. If it gets larger, then the value will not be that correct. But if that final velocity gets smaller and smaller, our acceleration will be more and more correct. So here is where calculus comes in, and that's calculus is a very efficient tool for finding a lot of this, and we'll dive more deeper into that in another video. So my challenge for you guys is to find the acceleration at this point without using calculus. If you know calculus, then it's not a lot of effort for you. But if you don't know calculus, it will be a challenge for you. And we are done.